Hello, I'm Mr. X, Mentor of Mathematics, and this lesson is Trig 096, square roots and absolute value. You need to know this stuff before you start taking a course called Plain Trigonometry. Before you go rushing into a course called Trig 101, take care of a few things like square roots and absolute value. Square roots. Something I've done with younger students, not so much older ones, but you'd be surprised how many older students just never got a handle on square roots. So if you find the first part of this presentation juvenile, just move on. But if it helps you, well, then I've done some good. The square root of 17 is the square root of 17. But as you read this, I want you to read it this way. The number that times itself gives us 17 is the square root of 17. The number that times itself gives us 29 is the square root of 29. The number we multiply times itself to give us 87 is the square root of 87. Of course, the square root of 16 is 4. The number we multiply by itself to get 16 is 4. The number we multiply by itself to give 107 is the square root of 107. And then, of course, the square root of 9 is 3. The number we multiply times itself to give us 9 is the square root of 9, which happens to be 3. When we say the square root of 17 is the square root of 17, what we need to understand is that the number we multiply times itself to give us 17 is the square root of 17. When we say that the square root of 29 is the square root of 29, we need to understand that the number we multiply times itself to give us 29 is the square root of 29. And when we say the square root of 87 is the square root of 87, what we need to understand is that the number we multiply times itself to give us exactly 87 is the square root of 87. And when we say the square root of 16 is the square root of 16, we can just call it 4. Because the number we multiply times itself to give us 16 is, by definition, the square root of 16. And that number is rational. And that number is 4. The square root of 107 is the number we multiply times itself to give us 107. And the number we multiply times itself to give us 107 is the square root of 107. And that number is irrational. And it's a little bigger than 10. You should know this. If we look at a number line, positive integers beginning with 1, here's 0, neither positive nor negative. Positive integers, just a very ordinary piece of a number line, then the square root of 107 sits on a number line a little bigger than 10. We might approximate that decimally with a calculator. A little more than 10 and 1/3. So it might actually be a little bit farther to the right here on our number line. Of course, these decimals never repeat and never terminate, because this square root of 107 is irrational. It cannot be expressed as the ratio of two integers. No matter how much we try, no matter how many places we use supercomputers to carry this out, the numbers never repeat or terminate. And that's a characteristic of an irrational number. We talked about the square root of 87. Where would that be? The square root of 87. Well, let's let our calculator help us out. The square root of 87 would be a little less than 9 1/3. Where's the square root of 17? Slightly less than 4 1/8. So the square root of 17 sits on a number line about here. The square root of 87 sits on a number line right about here. And the square root of 107 is, somewhere in here. They're really on the number line. But we cannot express them exactly as a decimal. But they're real numbers, and they're irrational. Now, what about our integers? Are those square roots? Well, sure they are. This is just as important as anything we've said so far. This is the square root of 1. This is the square root of 4. This is the square root of 9. 4 is the square root of 16. 5 is the square root of 25. You'll notice as we get farther along our number line, these square roots get closer and closer to one another. You want to be comfortable with these ideas before you start doing trigonometry. I'd like to ask the question, where is the square root of 45 on the number line? Where is the square root of 45? You should know it's between 6 and 7. 7 is the square root of 49. 6 is the square root of 36. So it's probably between 6 and 7. Of course it is. There's no probably to it. It is between 6 and 7. Here's the logic to that. The square root of 45 is greater than the square root of 36, but it's less than the square root of 49. Let's let our calculator help us out for a decimal approximation. It's a little more than 6.7. More than 6 2/3, less than 6 3/4. Little more than 6.7. I'll just ballpark it right there. Could we get closer to it on our number line? Could we zero in on it? Oh my goodness, yes. Absolutely. Let's focus on just the first 4 decimal places. To the nearest 10,000th. Square root of 45 is 6 and 7,082 10,000ths. You should know what number is halfway in between this value and this value. In other words, we could march 10 units to get from one to the next, to get from 0.708 to 0.709. What number would be in the middle? Do you know how decimals work? 6.7085. Might be a little easier to see if we add the 0 after these guys. They all start with 6.70. And what's halfway between 80 and 90? Well, 85. You need to be comfortable with this concept. Oh, and by the way, where is the square root of 45? Where's this number? Well, it's just ever so slightly more than that. So this number is going to sit on the number line right about there. Now this lesson is also about absolute value. Here are some absolute value bars, and we might ask the question, what's the absolute value of 45 minus 85? Well, let's see. Here's 45 on a number line. Here's 85 on a number line. What this question asks is simply, how far apart are these numbers? That's what absolute value does for us. Well, what's this distance? How far is it from here to here? I think it's going to be 40. Does that sound right? You want to get comfortable with the idea that an absolute value of a difference means the minus sign doesn't matter. It's simply how far apart. And this helps us in real life, not only in the study of trigonometry, but in all sorts of little ideas. For example, on a cold day. Here we have number lines that have been rotated 90 degrees, so to speak, to make them vertical. Think of these as thermometers, okay? We'll put red bulbs at the bottom of them to kind of help with that idea. Something such as that. But how far did the temperature rise if this was the morning low on a chilly day, negative 11 degrees, 11 below zero, and it got up to 21 degrees that afternoon? What's the temperature difference? Is it obvious that it's 32 degrees? That there's a 32 degree difference between 21 and negative 11? I hope so. You should be able to do that calculation instantly without a calculator. And if you can't, you need to practice. This should be automatic. What's the temperature difference between a morning low of 11 degrees below zero and an afternoon high of 21 above zero? You can add these absolute values. Add 21 and 11, you get 32. Boom. Just like that. So here's one for you to do. you need to know how far apart these numbers are immediately. What was the temperature rise if the morning low was 14 below and the afternoon high is 33? How far did the temperature rise? The better you are at this business, the easier trigonometry is going to be.